And there we go. Today we're going to talk about a hypothetical possible way of using blockchain and libraries. So let's just jump in and get started. I did start the recording. Thank you, SJSU, for hosting this. This is kind of like coming home. I'm a former student, so that's always nice to touch base with those guys. So today we're going to talk about community-based collections and how blockchain might be able to extend the library beyond the library. So I'm just going to really quickly go over this first slide. Essentially, I think everybody in the previous sessions has touched on this. So just making sure I'm getting some kind of an error here.
Right. I'm sorry, this is Debbie. That's the teleconference joining, and that notification will go away for you after a few seconds. If you see it pop up again, just ignore it for a minute.
Okay, thank you. So I think that the other speakers have touched on this, but just very quickly, for the purposes of this talk, just to remind everybody, the blockchain is essentially a shared ledger that lives on a network. It doesn't live on any one computer. It lives across many, many computers in the network. It uses math and the network effect to verify edits to that ledger and facilitates transactions without any trust between participants, and that's kind of a key piece to it. So now that I've said all that, I'm going to start a poll. If you could use your, oh, you know what? I didn't set the poll up, so we're going to skip that. Sorry. I meant to do that before we started. So we'll skip over the poll. I really apologize for that. Okay, so let's just kind of quickly go over a blockchain transaction, right? So we've got a person, they want to have a transaction, they send that transaction out to the network for confirmation. The network confirms it, and then it becomes, once it's confirmed, it becomes part of the blockchain. And once that is sort of memorialized in the blockchain, then that transaction is authenticated and the transaction goes through, and so the person on the right receives whatever has been transacted. And so it's all official at that point. There's a lot of use cases for how blockchain can be used. I think one of the more recent interesting ones that came up was there was a Chinese student who was trying to note that there was sexual assaults going on at Peking University with one of the faculty members there, and she was trying to bring attention to the fact that the professor was still there, and the letters that she sent to faculty to sort of highlight this were going nowhere, and someone, I don't know if it was her, but someone posted her correspondence and the history of this case onto the Ethereum blockchain. And so now that those letters are now there, they can't be censored, they can't be taken down, they're part of the Ethereum blockchain forever. There is a link there, so you'll probably need to get the slides later to be able to actually get that, to go to that. But if you go to this URL that's there, you can actually see the letters. They're attached as a note to that transaction. So that's kind of how that works. So there's a lot of really interesting ways to use the blockchain, and we're probably going to see all kinds of crazy ideas coming forward in the future that nobody can even imagine at this point. So some of the benefits of the blockchain are that, one, it's fairly private. I mean, as long as you're hiding behind the hash, it's anonymous. If someone figures out that you are connected to a particular hash, then your identity can be exposed. And some people who are using some of the the drug sales things on the dark web discovered this, that their identities were found because they were connected to a hash. So it's not completely private, but it can be pretty private. There's no middleman involved, so you don't need a centralized authority to authenticate or authorize changes or transactions that go on. And the verification is also distributed so that this is where the trust comes in. So as a block is verified as an actual transaction and the network agrees that this thing happened, that's where your verification comes from. And so it generates this trust out of nowhere where these actors who don't know each other, don't have any reason to trust one another, they can rely on this mathematical algorithm to generate trust between different parties. And what's also cool about it is that it allows for microtransactions. So, you know, with a credit card, for example, a lot of times the credit card companies will charge for every transaction, and so the merchant in a case may need to pay a certain fee to the credit card company for the right to use their credit card system in their store. But with the blockchain, the cost of using a blockchain currency, for example, are very, very low. And so you can have transactions that are just, you know, fractions of pennies, and it doesn't make it impossible to do because of the cost of actually doing business. And you can program these transactions so that there can be rules in place, as we'll get into in a bit. But the real killer app here is that the blockchain revolutionizes trust. It brings trust into transactions where no trust exists. And so that is really the key. And for the purposes of creating a community-based collection and a blockchain-based service around communities sharing things with each other, this is the real key part of blockchain for us in this talk. So suddenly, you know, peers out there in the world can share just about anything, and the trust is generated through this network effect. So what are we really talking about here? So really what we're talking about is a distributed library platform. The notion in this library, this extended library platform, is that anything can be a resource. It can be shared, and it can be shared by anyone with anyone. So it's totally open to anybody. Anybody can participate in this. And what are these resources we're talking about? Well, they could be traditional library objects like books. They could be art. They could be tools. They could be services. They could be skills and know-how. Really anything that you can identify using some kind of a digital hash, a digital identifier, could be shared as a resource using this you know, hypothetical system. So let's talk about how this system is put together. So the way that I'm thinking about it right now is that you would have a smart contract at the core. This smart contract would have all the rules about what is required to participate and who the people are and what the objects are that person may have to share, what objects are being shared at a particular time and what the state of an object is. You would have front-end code that would be that sort of user that would govern the user interface. So it might be a phone app or it might be a web interface. And then you would have this distributed app that that could bring together other blockchains to service different aspects of this service. So I'll get into all those things as we go through the talk. But let's start with distributed applications. So basically, a distributed application is composed of back-end code that runs on this decentralized peer-to-peer network. An example of that would be Ethereum, right? Ethereum is a blockchain technology, and it has back-end code that you can write smart contracts with. And then you might have front-end code that could be another blockchain technology like IPFS, the Interplanetary File System, or it could be a mobile application that's written in some other programming language. And then you can have, you know, this stuff on the front end can be written in any kind of, in any kind of language that you want, Java or JavaScript or anything like that. Distributed applications are pretty cool. They can be virtually uncensorable. They can be ubiquitous because they don't live on a centralized server. They live on the network. So the code exists in this network, just like in the blockchain. It's part of this sort of duplicated chain of blocks that exist on multiple computers around. So the code is always available and always out there as long as there are at least one computer that has this chain available for access. It's really the ultimate open source, and it's very fast. Because it's distributed, it means that rather than having to get your backend code from one server, you're getting it from multiple servers. So you're able to get bits of it from multiple resources, and so it would load a lot faster than, say, a traditional web-based application. So Ethereum is the platform that we would be looking at for this for a number of reasons. It's programmable, so like I said, you can program it. It has smart contracts are built into it, so you can write these contracts, and they can basically be anything you want. So these would be the rules. It provides a ledger so that you can kind of keep track of objects and individuals within the blockchain. It has a fairly good level of privacy, as I mentioned before. The record is permanent, so you know that if there have been transactions over time, that as long as they've been validated by the blockchain, they will be found in the blockchain. So that makes it also very durable. Ethereum also has a cryptocurrency associated with it called Ether, which allows you to create incentives for people who are participating in it in a number of ways. And then, it's interchangeable with other blockchains. So Ethereum can also be traded, or Ether can be traded with other cryptocurrencies, and Ethereum can also work with other blockchains. So let's talk about the smart contract a little bit. So the smart contract establishes the rules. So these might be things like the due dates on an item or the loan period for a given item. If there are late fees that might be based in tokens, these could also be established in the smart contract. And then the smart contract, as has been mentioned in a few talks already, can deal with provenance. So you can identify the item, you can identify who the original owner of an item was, what the current loan status is of that item, what the current location of that item might be, or in other words, who's actually borrowing it at the time. And then, the smart contract manages the ledger. So if there are credits to the loaner or debits to the borrower for not turning something in, if there's, you want to query the borrowing or loan history, you find it there. What current items are borrowed or loaned, receipts of return. So when something comes back to the original loaner, there would be a transaction that would be recorded in the blockchain in the smart contract. And then cashing out. So if you're in the system and you maybe, let's say that the system is, we don't know, but let's say the system is designed so that to incentivize people, they can either mine, that is, they can earn credits or tokens in the system, then they can cash those out at some point and convert those to something else. Or perhaps you earn tokens by doing certain things in the system. Like, so for example, if you provide a certain number of loaned items and those items are borrowed a lot, then maybe every time something goes out to someone, you get a token. You can, maybe there's a function for cashing that out. So that can be handled by the smart contract as well. And as I mentioned before, integration with other blockchains is great. You've got a lot of other blockchains that are being developed right now. There's very early in their implementation, but I'd like to go into a few of these just to give people a sense of what they are. So Uport is an identity management blockchain that's being produced. There's a number of others that are out there, but Uport's one that I'm kind of following. So this would allow you to create an identity that's fairly safe from someone hacking and getting all of your information, because the way it works is that you sort of have a hash that identifies who you are, and then you work with other agents out there. Say, for example, like for your passport, you would work with the passport agency, and they would, there would be a transaction between you and the passport agency saying that, yes, you have a U.S. passport, and you, are who you say you are, and that you have, clearance to travel out of the United States into another country. Using Uport, you could have that passport authentication on an app on your phone, and when you go travel abroad, you would be able to show, a QR code, say, and have that get scanned, and then the passport agent or the border agent would be able to verify just by scanning that you are in fact a U.S. citizen and that you have permission to travel and that you're allowed to come into their country. And they would, have their rules that would go through a process, and they would verify that you're who you say are, and then everybody's happy. But what would happen if someone was to hack into the passport agency, they wouldn't necessarily get your library card number or your California driver's license or your address or something like that. They would only get your passport number and your date of birth and your name and a couple other pieces of metadata. So in using something like this for identity management, it sort of protects the user, it reduces the risk of identity theft. And so this application that I'm describing could work with these sort of other blockchains for identifying the participants and sort of verifying who they are. So that's Uport for you. IPFS and Filecoin, this is a big one. IPFS, the Interplanetary File System, is a blockchain-based protocol that's being developed to sort of sit side by side with the regular internet. So if you go to CNN.com right now, you have to query a centralized server to get a web page that has to be downloaded from that server. IPFS uses a distributed network of computers in a peer-to-peer fashion so that you can make a call out to a particular hash, which is a website, and then all the peers out there on that network that have that file, that website on their computer will start sending you the little bits. And then you will download that website from the network rather than from one central server. So the IPFS is cool because, one, it foils the attempts by censors to censor the internet and censor free speech. It allows people to get web content much, much quicker than through a regular HTTP or HTTPS method. And it's associated with Filecoin, which is a cryptocurrency that's being developed to incentivize people to host web content and to facilitate the transactions between people calling for websites and people delivering websites. So in the scheme of things, this can sit right next to a regular, if you're in your regular Firefox browser or your Chrome browser, you'd be able to go and navigate to any web page. But if you also wanted to check out stuff on IPFS, you would only have to just put in a URL just like you normally would, except the URL would have a hash in it that would take you to another place. And here in Palo Alto, we're actually playing quite a bit with IPFS. We've, as an example of what you can do with it, we posted a Gutenberg copy of Tom Sawyer to IPFS, and so that's now available out there, right? A banned book now available on IPFS, and as long as we're hosting it and somebody else maybe is hosting it, it's out there and can't be taken down by any authority in a place where that book might be banned. So kind of an interesting technology. It's also being developed. And again, like your front-end code can live in IPFS. You can post your front-end code into IPFS, and it can be in the network, and so it can also make it difficult for people to take down your service as well. So it also improves that fortification against hackers and against other agents that might want to take you down. And like I said, Ethereum and Ether, this is where the smart contract and backend code can live. And so this application that I've been describing can kind of incorporate that too. So all of these things can kind of come together to form this community-based collection where you can open it up, open up your community for people to share things. It can be digital content, it can be physical items like tools or books or whatever, as long as there can be a way to identify the item in question or the person in question with a hash, you can share it. You can track where it is and who's got it. And so this is kind of the idea of this community-based collection. So again, it sort of takes the sort of service that libraries have traditionally provided for our communities and creates a way to open up sharing around the community beyond the library walls. So, oops, looks like I wasn't going ahead of my slides. So just so you know, all these things are in here to kind of augment what I already said. But I will open it up to questions now. If you have questions, go ahead and enter those into the chat. So somebody's asked, how is IPFS different from a torrent? It's actually pretty close to a torrent. There is blockchain behind the way IPFS works. So it uses hashes to identify a particular digital object, and there's a transaction that goes on in there. And also, like I mentioned, Filecoin is involved, which is another blockchain technology. And so, as people are facilitating the exchange of IPFS content, so for example, I'm hosting Tom Sawyer on my computer, I'm making it available to the world, I can earn tokens, I can earn Filecoin by simply hosting that content. At the moment, Filecoin is not out there it's not available for people to use yet, still being developed, but IPFS is available, and I urge you to, go out there and look into IPFS. It's very easy to get set up on your computer. Actually, Palo Alto is hoping that we're going to be able to start helping other libraries get involved with IPFS soon. So hopefully there'll be an announcement of that in the near future. Going to see what other questions we have. So we haven't set up this application. This is very theoretical at this point. I will be taking this concept to the Blockchain National Forum this summer, and we'll be discussing it in more depth. I think some of the issues that were brought up previously, the legal stuff, the security issues, the standards especially, those are really good questions that would need to be worked out. I mean, this concept is quite large, as you can imagine. It would probably require a lot of people participating in it, definitely some kind of grant behind it with some programming budget and a lot of people thinking about it. Obviously, when you're writing code, you need to be, especially when there's goods and services involved in it, there's going to be, there's going to be a lot of security that needs to be vetted in something like this. So, so no, we have not started on this beyond thinking about it. So somebody says, potentially if someone is in a war-torn place and wanted to provide information, no one would be able to take it down. Actually, in IPFS, or in Spain, when the people in Barcelona were looking to secede from Spain, the Spanish government took down their website, and so the activists put their content in IPFS so that it could be available to anybody who wanted to read their manifesto or learn about their issues. So IPFS is live. It's actively being used right now to thwart censorship. Just kind of going through to see if there's any more. I assume that these slides are going to be made available. Oh, here, somebody's actually said how you can, under File, you can save the slides as a PDF. You know, also my contact information is there, so if you want to send me an email, I'm happy to answer any other questions that we don't get to today. So as you guys are drifting away, I just want to thank you very much, and you know, stay tuned for more updates on you know, this project. We're hoping to involve other libraries in it. So thanks very much.